And now for our final team, NeuroSleeve.
Thank you. Thank you. Thank you.
Yes. Body pack first, a little box first. Body pack first, thank you.
I'm going to tell you a story about a patient called Akash, who I saw last year during my medical residency in London. He had come over to us from a developing country and had been complaining of pain and weakness in his hands for many years. He was finding it difficult to perform even simple tasks, like doing up the buttons on his shirt, or holding a spoon to feed his children. When I examined his hands, they looked something like this, with massive wasting of the muscles around the thumb.
You probably want this.
Not so. So, should we start from the beginning?
Bring it on.
Fair enough. You're going to hear that again. So I'm going to tell you a story about a patient called Akash. Fair enough. Basically, when I examined Akash's hands, they looked something like this, with massive wasting of the muscles around the thumb. We sent him to have specialist tests performed on the nerves in his hand and found that he was suffering from a disease called carpal tunnel syndrome that had gone undiagnosed for over a decade. Now, carpal tunnel syndrome occurs when one of the main nerves of the hand gets trapped between the bones and ligaments of the wrist. This can progress to become permanent, irreversible nerve damage. But if it's diagnosed early enough, it can be treated with a minor operation to the wrist. Now, unfortunately, Akash's story is not at all rare. Carpal tunnel syndrome is the single most common entrapment nerve disease in the world and affects 367 million patients around the world. Of these, 284 million live in the developing world, and about half are patients just like Akash, who, if they had been living in the United States, could have had a minor operation that would have saved the function of their hand.
We'll see if this might, there we go. So if it's 50% and it's a relatively minor surgery, then what's the problem? Well, the problem is diagnostic equipment. The current diagnostic equipment is currently not compatible with developing countries. And there are three main reasons for this. The first is cost. These machines cost upwards of $30,000 to $40,000 per unit, which translates into very high per patient costs. The second reason is, as you can see on the screen, they're very large, they're bulky, they're fragile, and they have very, very clean power requirements. Developing countries don't have this. Lou and I have had the privilege of working extensively in developing countries in prior lives, and we found that we want to make a device that meets these strict requirements. And finally, the device that you see on the slides, the latest in tech, requires a specialist, a highly trained specialist. This increases cost and also adds to patient delay. And that's why Lou and I are excited to talk about NeuroSleeve. NeuroSleeve is a standalone carpal tunnel diagnostic device, and it addresses all three of the problems that we just talked about. For cost, it is 2 orders of magnitudes less than the technology we just showed you before. As you can see, it's portable. We carried it out on stage, and more importantly, it has its own dedicated power supply. And finally, and something that we're incredibly proud of, it does not require a specialist. Instead, someone like an American nurse or in India, a village healthcare worker can be trained to use this device. Lou is now going to do a live demo to show you how easy it is to use.
So the device is now sending an electrical impulse into the nerves in my wrist, which is being conducted into my hand and causing my thumb to twitch. It is then analyzing the electrical activity of the muscles in my thumb and extracting key pieces of information that are used in making a diagnosis of carpal tunnel syndrome. I have had my nerves assessed using the current gold standard technology and was found to have a key nerve conduction value of 3,600 microseconds. We just ran a live demonstration for the judges and read a value of 3,648 microseconds, which is exactly what we would expect given the professionally obtained measurement. Anything greater than 4,500 microseconds is highly suggestive of carpal tunnel syndrome and means that this device is currently confirming that my hand is disease-free. More importantly, when we ran this device on Matt's hand earlier, it also confirmed that my nerve conduction speed is faster than his.
That was definitely not in the previous presentation. All right. So let's talk about the progress that we've made. So Lou and I first talked about this problem. It was about 6 months ago. We met in the bottom Kendall T station, and we were like, how can we solve this problem? We developed a proof of concept unit. Most of you saw us participate in the 10K process, and we took that prize money, and then we poured it into the product that you see before you today. We want to continue moving this forward, and to do that, we need to do 3 key things. The first is that we still need to collect more clinical data measured against the gold standard that's used at hospitals like MGH. The second is we need to obtain FDA approval. Now, fortunately, we qualify for this process called the 510K process. It lowers the amount of time that we need to do to get this serviced, but it still takes time. And lastly, we're working with contract manufacturing device makers that provide us the experience as well as the manufacturing expertise to produce this, as well as we get their distribution channels as well. Yvette, Lou, and myself, we have a bunch of really incredible advisors that have helped us from the medical side to the business side, as well as filing IP. We're incredibly thankful to have your time. We want to continue pushing this product forward with your support to help people like Akash and the hundreds of millions of people around the world to get the medical care that they deserve. Thank you. Nice job, buddy.
Thank you, Lou. Thank you, Matthew. Understanding the critical importance of getting FDA approval on a medical device, can you talk a little bit about your approach to that process and what you're anticipating?
So we're fortunate in that we qualify for something called the 510K process for the FDA, which means there are previous predicate devices we can base our application on. So we use electrical parameters that are well within FDA limits, and that means it's far easier to get it approved, and it's also a much shorter process than the full approval process.
So you started this was an idea in December 2016, and in span of a few months you have working prototypes, so congratulations. My question is, how did you make such fast progress, and what were the key insights that were driving this invention?
So the key feature behind this, and the thing that we filed a provisional patent on, is the combination of tests that we're using. They were selected from a sort of plethora of tests you can use to diagnose carpal tunnel, and they were chosen because they are A, very cost-effective to produce, they have a very high signal-to-noise ratio, and they're incredibly specific for carpal tunnel. So once we had that exact combination figured out, the rest of it made the whole process much easier.
Lou is being a little bit humble. He's actually a very, very good doctor, and that helped us a lot. I was also able to apply techniques I learned in the defense industry for the signal processing on the electrical side, and it made that process speed up dramatically.
Great. Thank you very, very much.
Thank you. I got this side.
Oh, give it in back. All right, so that's it for our pitches for tonight. I'd invite our judges to please leave the room kindly and respectfully to deliberate and decide on the winner. That's tough work you have ahead of you. All right. We will let them leave.